Hi everybody, welcome to part 10 of the Bravo project. Today we're going to focus on an extra module called the Flash Programmer. If you have watched the previous video, in memory module we actually had a flash memory. We are also going to have some flash memories later on in our control logic circuit. And therefore, we need to actually have a way of writing data into those flash memories. So essentially, in order to program these flash memories, there are two different ways of doing it. One way would be just to use one of those more professional EEPROM or flash programmers. This is a Minipro product. And actually, I'm going to show you in this video how to use this Minipro to program your flash. Or you could just build a simple circuit, which we call it the minimal flash programmer, and this is actually part of the original minimal project that has been designed by Carsten, and we're gonna basically build this circuit and use it to program our flash memories. Now, this is a very simple, cost-effective circuit if you don't have one of these flash programmers. If you have one of these more professional ones, then probably you don't need the flash programmer kit. However, if you don't have a Minipro, you're probably gonna need this flash programmer to basically program your flash memories. Now, this is a simple circuit. Actually, it consists of a couple of parts. And even if you remember from the Ben Eder's 8-bit computer, he also built an EEPROM programmer, a simple one on breadboard. And essentially here is the same concept. We are using an Arduino Nano as our interface. And basically, then we have a simple circuit with a pair of 74 HC595s, which are basically our serial to parallel converters. And then we have, our flash memory socket here. So once we build a circuit, we just, insert the flash memory here. And then Carsten also has developed a sketch for these specific flash memories that we're going to be programming. And basically, we're going to interface with that and write into those memories. So let's build the circuit, and we're going to actually have a look at the circuit design, and then we're going to build it, and we're going to actually use it to program our flash memory. All right, so before getting started with the circuit behind our flash programmer, let me just give you a big picture here on what we're trying to do here. So first of all, we're going to have 3 flash memories in our computer. One of them is the SF040, which is the 512 kilobyte version. That's going to go into our memory module. And we talked about this chip in the previous video. We actually write a sketch to program it and so on. However, we'll be using 2 more of these chips, except that those are the lower capacity versions at 128 kilobytes. And the part number for those are SF010. Those 2 chips will be used in our control logic later, and essentially they will be saving our microcode that we will be using to actually output the control signals on that control logic. So at some point we will be developing a microcode for our computer that needs to be saved on those chips. And in fact, once we did that, then those chips will be play the role of ROM or read-only memory in our computer, meaning that we will not be writing to those chips and we will be reading all the time. Therefore, we need just a flash programmer to write that data into those chips and basically be done with them. Now, in order to write to those chips, we could use either of these solutions that are shown on the screen. We could use a Minipro, which is like more a professional EEPROM IC programmer, or we could use this little circuit here, which is called the minimal flash programmer. Now, in long term, if you're doing a lot of these circuits, probably would be a good idea to get one of those Minipro flash programmers because of the wide range of the ICs that they support. And you could test and basically program different type of EEPROMs, flash, and so on. However, for this project, if you want to be on budget, then this minimal flash programmer works just fine. Except that obviously this minimal flash programmer is kind of customized around this project, and basically you would be able to use it to program these flashes that we have here. And maybe if you actually change the sketch later, maybe you could make it compatible with other different type of ICs and so on. Now this is really all about the control logic side. However, on the memory side, later on we probably will be developing let's say an operating system, an assembler, and so on. We could also use these flash programmer here to write that data actually to this chip. Because if you think about it, when I was describing the circuit for our memory, I told you that when the computer actually is turning on, the first address that will be pointing to is the address 0 on this flash memory chip here. Therefore, if you put any instruction on this memory chip, essentially that's going to be the first instruction that's going to be executed in our computer. So that's going to give you a good idea that what could be actually the purpose of this flash memory in our computer. Therefore, if we, let's say that write some initialization code on this flash memory, then we could essentially start the computer and point it to a specific memory address that then it could basically fetch another instruction from a different memory address and continue the operation. Now that's the purpose of having these flash programmers here. However, once you build the computer and you kind of had a microcode and let's say an operating system and so on, then you could actually write to this flash in our memory module directly from the inside the computer, meaning that you don't need an external flash programmer. And that's what we actually talked about in the previous video, right? We have some sketches, and we went through actually the write operation and sector arrays operation and so on, so that we could write to that flash memory right on the board. The only thing is that, as I explained in the previous video, in order to do that, you probably need to obviously write some code and maybe develop a little file system that could actually perform those operations in order to write to the chip. But again, just I wanted to give you a big picture here so that there is no confusion that what we're doing here, why we need a flash programmer when we could actually write directly into the flash chip. All right, so with that, let's go ahead and have a look at the circuit behind this minimal flash programmer, and then we're gonna build it and basically use it to program some of these flash chips. All right, so let's have a look at the circuit behind our flash programmer. As you can see, we have an Arduino Nano board here, which is connected to a pair of 74 HC595s, and the output of those chips are going to a socket, a 32-pin socket here, that we will be using to mount our flash chip and essentially use the Arduino Nano to program it. Now this circuit is very similar, at least on the functionality side, to Ben Eder's EEPROM programmer. I put a link into the description for his video, and I would highly recommend that you guys watch that video if you're not familiar with the shift registers and basically how these serial in, parallel out type of circuit works and so on. He goes into details of describing how this circuit works, and actually he's building pretty much the same thing in that video. However, here I try to give you a high-level overview of the circuit and how it works, but again, that's an option there if you want to go into more details. Now the point is that on this flash chip we actually have a bunch of pins that we need either to address or send data to. And if you remember from the previous videos, we talked about that for a 512K flash memory chip, we actually have 19 address lines. So we have 19 address lines there, and then we have on top of that another 8 lines for the data that needs to be sent to the chip, and also we have a couple of pins, to control the
let's say, write enable or output enable and so on. So the challenge here is that with this, smaller development boards like an Arduino Nano, we actually do not have enough, digital pins to cover all of those pins. Therefore, we need to come up with a serial to parallel converter or shift register that you can see on the screen. So the idea here is that to actually send out the data from the Arduino Nano on a serial line, bit by bit, and then using a small circuit that you see on the screen, we kind of convert that from a serial in to the parallel out, meaning that the data that is actually going out of, let's say, pin D10 here on our Arduino Nano come into the serial in of the 595 chip, and with each clock pulse that this chip receives, it puts that bit on the output lines, the parallel output lines. And once we converted that serial data into parallel output, then we could connect those parallel lines directly to the address lines of our chip and basically address the flash memory. Now, some details about this specific circuit is as you can see, we have two 595s here, and those are actually cascaded together. Now, the serial data from the Arduino Nano is coming to pin number 14 on the chip on the left-hand side. As you can see, it's a serial in pin, and then we have the also serial clock pin, which is pin number 11. Essentially, you just send a bit of data and then pulse the clock, and with each pulse, that bit's going to go to the output side. Well, not exactly to the output side. It actually goes into the buffer, but let's for now assume that it goes to our output lines. And also these chips, as you can see, are cascaded together. So the most significant bit from the chip on the left goes to the serial inline to the chip on the right-hand side. Therefore, let's say we are sending 16 bits of data. Essentially, each time that we send it, those data will be shifted to the right here, and once it reaches the most significant bit of the chip on the left-hand side, it's going to basically move on to the next chip and so on. Now, this is really all about the circuit. We also have actually another thing here. In these 595s, we have an internal storage, or let's say a buffer thing, that when the data comes in on the serial lines, it actually does not put the data directly on the output lines. It kind of saves it in a buffer type of thing, and in order to output that buffer, you actually need to clock pin number 12, meaning that with the initial clocks, all the data will come into the buffer, and then once the data is set in the buffer, you should basically clock pin number 12 so that the data actually shows up on the output. So that's how the Flash programmer works here, and with that, let's go ahead and build this circuit, and then after building it, we're going to actually load a specific sketch developed by Carsten into our Arduino, and I'm going to talk a little bit about the sketch and how it works. But once you loaded that sketch, then you could send data through your computer to this Arduino Nano, and then that data will be written into our flash chip. All right, so let's go ahead and build this circuit.
All right, so now that we have built our flash memory programmer, I guess we are ready to, just insert our flash memory in here. Should be quite easy, hopefully. And we just need to connect our USB cable and load a sketch to our Arduino Nano. All right, so let's go ahead and load the sketch and see how we could actually write into our flash memory.
All right, so I'm ready to actually test the Flash programmer. But before doing so, we need to actually have a file to write it to the flash memory. And in order to write data to these flash memories, you first need to create a binary file, meaning that that data needs to be written into a binary file, and then we could transfer that binary file into the flash. Now, the binary file is essentially just a file that has all the bytes written in a sequence in the file, which is different than a text file. Let's create a file together, and then we can look at it and see what it is. So here I'm using Python, just because I have Python installed on my computer. So we write a very simple Python script to generate that binary file. So let's first create, let's say, a Python list. So we could say number array. Let's say it's just a simple Python list, which is essentially just an array. And then we're gonna maybe create a loop. So let's say for I in range, let's say 256. And then we are gonna actually populate that number array with these values. Number array, we're gonna append. We're gonna append the I. And I guess that's it for now. We could just, print actually the number array on the screen just to show you guys what it is. So again, it's a simple thing. We just created a variable. It's an array. We're gonna count from 0 to 256, and then essentially gonna append each of those values to the array. And then we're going to print the whole array on the screen. So let me save that. And if I run Python, the name of the file is actually data2bin. And we have an error. So let's see. Did I mistype? Oh, yeah. Range. OK. So let's rerun it. All right. So as you can see, I just have an array, and I have the values from 0 all the way to 255 inside that array. Now, if you look at the screen, this is actually a text value. So when we are printing it on the screen, or even at this point, if you want to actually write that to a file, this is going to be written as a text. And that's not what we want. So we want to actually the data to become a bytes, and then the bytes written to the file. So in order to do that, Python has a function, and that is called the byte array, which basically converts the text to byte arrays, or let's say convert a text array to a byte array, and then write that. We could write that basically into the file. So in order to do that, let's just add data equal to byte array, and then we could just take the whole number array and actually convert it to the byte array. All right, so I guess that's it. And then this time, instead of printing the byte array, we're just gonna print the data. So let's run again the script and see what will happen. So now, as you can see, this time we are not actually printing text on the screen, but we are actually printing a byte array. And that byte array consists of all the values different bytes, and this is basically equal to the byte which contains 0, and this is the byte for 1, and so on, up to 255. But interestingly, if you look at this print, you see that actually for some of them we see the alphanumeric characters and numbers are printed on the screen, and that is normal because the byte value actually for those characters are equal to that specific value. Essentially here, when we are printing on the screen, it is actually converted back to the ASCII character, and that's why we see the ASCII character. Otherwise, this is still basically just a byte. So now that we have all of those values, what we could do, maybe you could just write it to a file and see what will happen. So instead of printing it, let's say open a file. So with open, we could say let's call our file data.bin, and as you can see, I'm just giving it a bin extension. You could probably give it any extension, doesn't matter, but by convention, binary files are have an extension of bin. So, and then we're gonna say that's gonna be write binary to the file, and we could say this is our output file. Right? And then what we could do at this point is just do a output file. Then we should write the data into it. The data that we had, we could just write it into that file. So here I'm just taking the data that we printed on the screen, and I'm just gonna write it into a binary file. So let's run it and see what will happen. Let's clear the screen and run it again. Now this time we should have an output, which is the data bin file. And if I actually look at that file, there's two ways we could look at inside that file. One is using the hex dump utility, which probably you need to download and install it on your system. So we could just say hex dump, and we just specify the file data bin, and as you can see, we basically have a sequence of bytes written to the file from 0 all the way to 255. So there's one way, and there's another way. We could just use these text editors like the Notepad++. So I could basically just open this file here, and as you can see, when we open it using a text editor, it shows actually as some gibberish. However, as I said, this is a binary file, so in order to see those, you could install a plugin, for example, on Notepad++. I think it's called the Hex Editor, if I'm not wrong. I've already installed that. Yeah, that's called Hex Editor. And once you had that, you're going to get an icon here that you could click on it and actually see the file in hex format. Now, as you can see, hex viewer or editor shows the addresses. Also with the hex dump, we saw the addresses from 0 all the way to, let's say, 255. However, these are just the location of these bytes. In fact, these are not in the file. Remember that in the file, what we have is just the bytes, the individual bytes that are right in the sequence. But again, these editors just show you the address and also the content of each address. So I guess that's good. So now we could do another thing. So let's just generate a little bit more data. What we could do, probably we could add another for loop here, and this way we would be able to generate more. So let's say for this time j, let's say j in range 256, we just wanted to generate that. And yeah, I guess that's good enough. So what I'm doing here is basically I'm creating another for loop. So essentially with the first for loop, we're going to go from 0 to 255. And also inside that, I have another for loop, which goes from 0 to 55. So that value that actually needs to be written previously as 1 byte, this time, because we have a for loop inside it, it actually will be written to 255 bytes or 256 bytes. So essentially, each value like 00 will be repeated 256 times, and then 1 will be repeated 256 times, and so on. But this way, we are actually generating a much bigger file. And if you multiply those together, 256 multiplied by 256, we should come up with a 64K of data. All right, so let's run it and see what will happen. Let me clear the screen, and this time we're gonna, repeat it. Now, if we say, all right, now we have a data bin, and let's just do a hex dump on data bin, and looks like we still have the same thing. Yeah, I guess I didn't save the file actually, right? So let's first save the file and run it again. So now if you do a hex, yeah, this time you see that we got much bigger data file. So in fact, if you look at the file now, we need to refresh it, and so as you can see now, the value of 0 actually repeating for 256 bytes, and value 1, and so on. So again, it's just a simple example to just populate a file with different values, and this way we could just have a data file that we could write into our flash memory and verify the write and read operation. So now, in fact, if you look at the file this time, you see that the data bin file that we generated is actually 64 kilobyte, which is consistent with what we have done here. We basically wrote 256 by 256 bytes, which results in 64K. All right, I guess now we have the file, so we can go ahead and let's write this file to our flash memory and see what we get. So writing the file to the flash consists of 2 steps. The first step is actually to upload a sketch that has been written by Carsten into our Arduino Nano. And here is the sketch. As I said, this is actually developed by Carsten Herting. I'm going to go through the sketch really quick to just give you an idea how it works. So in this sketch, Carsten actually has been using port groups rather than, defining the ports individually and using the digital write and digital read. He has been using the port groups and also the bit write function in Arduino. This is a different way of accessing Arduino port. So essentially, there are plenty of documentation on this online, and this is just basically part of the standard design of the Arduino boards. So if you, for example, look at an Arduino Nano board, you see that we have, those individual digital pins that we could actually have access to. We could define it in our sketch as, let's say, specific pin, and then using digital write or digital read, we could interact with them. However, all of those pins are also have been assigned to a specific group. So for example, here you can see that some ports are actually part of the port group B, some of them are part of the port group A, and so on. And essentially, when a port goes into a specific port group, it has a bit value associated with it, and by just setting that bit value to 1, you basically bring that pin high, and if you set the bit value to 0, you bring that pin to low. So that's what you see happening here. Again, if you're not familiar with port grouping and so on in Arduino, I guess there's plenty of information online that you could find. However, here I'm just going to go ahead and show you the sketch. So again, as you can see, first of all, we have a read size that specified as a hex value. I'm going to come back to that later. This is basically the size of the data that we could read after the write operation. Again, as I said, I'm going to come back to that value in a minute. But for now, let's just look at the some of the operation that he's doing. He's basically doing like setting some of the pins to high or low depending on the state of the program. For example, here we have an output enable, and this is basically on the 74HC595s. And then we also have the write enable, which is basically the write enable on our flash memory. And again, he's pointing to a specific port group and set a value for them. He's kind of initializing everything here. And then the main part is actually starting from here in the loop function. And as you can see in this loop function, after initializing some of the port groups, he's actually opening a serial connection and leave it open for the data to be received, meaning that in the for loop we are continuously reading the serial line on our Arduino Nano, and we're waiting to receive a specific value and the data. So meaning that when you actually load the sketch on the Arduino Nano, it will continuously will be waiting to receive the data through serial line, which obviously in our case, because we're connecting our serial connection to our Arduino Nano through USB port, then Arduino Nano will be waiting to receive the data on that line. And so I know that it may not be clear so far, but just bear with me for a minute. So again, there are two operations that is happening here, either write or read. And he has written a couple of functions here. So for example, the set address function here is basically getting an address, and as you can see, the first 16 bits are actually set through the port B here. And if you remember from the schematic, I said that you're gonna set the first 16 bits through the 595s. However, the last most significant bits are actually directly set on the Arduino board, and that is what is happening here to set an address. And then of course to read, again, he's bringing some of the ports high and low. As you can see, for example, in port group C, there are a bunch of ports in that group, and obviously you should know which port is associated with which bit here, and therefore you could basically set those pins high and low, and that's what he's doing here, essentially bringing some of those signals high and low so that you could read or write to the pins. And finally, when you want to write a data byte, as you can see, we are passing the data into write to function, and then again, that data is actually written again to specific ports which are connected to our data pins in our flash memory. And there are really two important functions here. One of them is the erase flash, and in the previous video when we were talking about writing to the flash memory, I talked about writing to a specific sector, and we were basically cleaning that sector before writing to it. However, here, since we are writing the whole file to the flash, what we could do is that we could erase the whole flash, and that's what will happen. Basically, at the first step in the write operation when we send data to our Arduino is basically to go ahead and first erase the flash, and that's what will happen here. And as you can see, again, we are following a specific procedure to erase the flash. I guess I talked about those in the previous video, that you need to write a specific value to a specific memory address, and that's what is happening here. And eventually, once we erase the data, then we could write the data into flash. Again, that's where we're passing the data and basically use the 3 steps before the writing and then finally we write the data to flash. So basically what is happening here is that once we loaded that sketch on our Arduino, we are done with the first step. And this step really needs to be done only once. Once you uploaded the sketch, it's going to be there forever and you're done with the sketch. And the next step will be basically to just run another utility or another program that Carsten has developed. And every time that we want to write something to the flash, we're just going to use that utility. So now that my Arduino is connected, I'm just gonna double check the sketch, and I'm gonna upload this sketch to my Arduino. And that's it. Now we are done with step one. Again, that's a one-time upload. Once you upload it, you don't have to upload the sketch again to the Arduino board. Okay, let's move on to the next step. So next step is actually running a little program written by Carsten again, and it's called prom.exe. What I've done, I copied that file here, which is called prom.exe. And by the way, I'm going to post all of the files that you see here on GitHub page, so you could download those and use those. So as you can see, we have prom.exe here, and that's the utility. I think it's written in C++. But again, I guess at this point, probably we're not going to go into details how this works. This program, essentially what it does, it reads the data file, and this is the data file that we generated a couple of minutes ago using the Python script, and that contains 64K of data. So what this prom.exe does is that it's reading this data file byte by byte, and then it sends it over your serial port. Whatever your serial port is active right now and connected to your Arduino, it's going to take that and basically send it byte by byte, along with a flag, which is basically the write flag. As you can see in the sketch, we have the write flag. And then from that point, what will happen is that our Arduino receives that data on the serial line and basically takes the data byte by byte and goes through those functions that I described and write it into our flash memory. So now going back to this function, if you basically just type prom.exe, you see that we have a little help here. And so in order to write a file, you have to just specify the argument -w and then specify the file name. And then in order to read the content of let's say an EEPROM, in this case it's a flash memory, and save it to a file, you need to use the -r argument. So I guess we could just go ahead and actually write this file to our flash. So what I'm going to do, I'm just going to say prom.exe, and we specify -w and the name of the file, which in our case is data.bin. Now if you hit enter, as you can see, in my case, my Arduino actually is connected to COM4, and as you can see, it's reading actually the 65K of data. It even do a checksum, which is great. And then now it's writing that data to the flash memory. Now the data, once it's written, it verifies it, and it looks like we have 0 errors, so that's great. And then as you can see here, it's also doing a check after writing the data, and that's where you could see that reading only 8K, and this 8K actually is coming from this value that we specified in the sketch in the as the read size. As you can see, it's a value of 2000 in hex, which is basically equals to 8K of the RAM memory. If you want to read bigger chunk of the data, then we could just change that number. For example, if you change that to let's say 4000 in hex, that's going to read actually 16K of your memory. But again, that's the relationship here really. With that, we just wrote actually that data into our flash memory, and we could check that. We could basically, let me clear the screen. What we could do, we could actually read the data from the flash now and write it to a file. So if you remember from the prom.exe, another parameter here is -r. So what we could do, we could just do prom.exe, and then we could do -r, and then we specify a file name to basically when the data is written from the flash memory, it will be written into this file. So let's just call this data 2.bin, and as I said, we will be reading only 8K of the data because this is what we have specified in the sketch. And now if we actually look at our directory, you see that we have a data2.bin which is only 8K. Now what we could do, we could actually hex dump this. So if you could hex dump exe data2.bin, you see that we are actually reading the same data. So that means that we actually wrote the data file that we created, using that Python script. We wrote that into Flash, and then we read it back to a different file here on the screen. And in the read back operation, we are just only reading 8 kilobyte, but obviously we could, change that number and read more if we needed. So that's how you use this, minimal Flash programmer along with the sketch and the prom.exe, application to write data into our flash memories. Again, as I said, the first step, uploading the sketch, is a one-time operation. Well, unless you want to change that value to anything else, but you could just upload this sketch into your Arduino Nano once. Then once you're done with that, you could always use that prom.exe to either write data to your flash memory or read from it. All right, so with that, I guess we are done with the minimal Flash programmer. However, as I promised, I would like also to show you the procedure to write the same file to our flash memory using the Minipro Flash programmer. All right, so let's see how we could program our flash memories using the Minipro device. Minipro comes with some applications that you could actually download from the manufacturer website. In my case, I have the Windows version, which is called the XG Pro, but I guess they have the command line version and also probably some versions for Mac. So depending on your computer, just download the appropriate software, and then once you install it, it has a very nice GUI to interact with the device. Now I took the flash memory that we just programmed using the minimal flash programmer, and I mounted into a Minipro device, so it's ready to go. Now one thing that you could do here is just basically search for the type of IC that you want, and the beauty of this device is that it supports a very wide range of ICs and flash memories and ROMs and everything. You could actually use this device to test and also program different type of ICs. So in our case, we basically need an SST and 39 SF, let's say 040. And as you can see, even in this with this manufacturer, there are different ICs, and the device has support for really wide range of ICs. So here we need actually the SST39SF040, so we just select that one, and now we're ready to basically read or write to that. So first, let me just read it. So I'm going to click on the read, and if I actually read the data, it's going to show the data, and as you can see, this is actually the data that we just wrote to the chip, right? When we were doing it using the minimal flash programmer. So the first 256 bytes are 0, the next is 1, and so on. So this is the read operation. However, we could just simply click on erase, and that's going to erase the whole chip. So that's another cool thing about this. And if we read this time, you're gonna see that the flash memory actually reset it to factory default, which means that you're gonna have FF on all memory cells all across the 512K. So now let's write data to this same flash. So in order to write the data, first you need to open the file. So I'm gonna load the file, the same file that we created using the Python data.bin at 64 KB, and then I'm gonna open it here. So at this point the file is open. As you can see, we see the same data. And finally we could just click on program, and by doing so we are just writing this data into our flash, and that's it. That's how simple it is to actually write the data to our flash using a Minipro. All right, I guess we covered everything, different ways of writing to our flash memory, and I hope that this video has been informative to you guys, and I'm going to see you in the next video, which we'll be talking about the UART module, which is quite exciting. All right, see you there.